This video is a continuation of the last video, and in this example we're going to go ahead and sketch an example of a rose. This is given by the equation r is equal to sine of 3 theta, and we'll be doing this like we sketched the previous graph. First we'll go ahead and graph our function in rectangular coordinates, then we'll discover how our r changes as our theta value increases. This axis is our theta axis, this axis is our r axis. Now let's go ahead and look at our function a little more closely. R is equal to a sine of 3 theta. And we want to find what happens to our graph between the values of 0 and 2 pi. So one thing we know about this function in particular is that it has a period of 2 pi divided by 3. And another thing that we found out is that our function is going to be symmetric about the line theta is equal to pi divided by 2. Therefore, to graph this function, we really only need to figure out what's happening between negative pi divided by 2 and pi divided by 2. Let's go ahead and add in our theta values where our graph hits either 0, 1, or negative 1. Now sketching out our graph, we'll get a graph that looks like the following. Let's go ahead and start a new page. So looking at this graph, let's also label these points. This will be our point 1, 2, 3, 4, 5, 6, and 7. And we'll write these points in polar coordinates. This is our r value, this is our theta. Writing these points down, let me go ahead and note that we could rewrite negative pi divided by 2 to be equal to a negative 3 pi divided by 6 for simplicity. Then we'll get the following list of points. And we're going to go ahead and graph this on a polar coordinate system. And remember, these are given by the following names. This is point 1, point 2, point 3, point 4, 5, 6, and 7. So point number 1 should be around here. Point number 2 is here. Point number 3 has an angle of a negative pi divided by 6, so somewhere in this direction. But our r value is negative, which means our point should be over here. Point number 4 goes back to the origin, so we have a double point here. Point number 5 is pi divided by 6, 1, so somewhere over here. Point number 6 is again at the origin, so we have a triple point. And point number 7 is at pi divided by 2, but again we go antidotable, so we have a double point here. So let's see what happens to our r values as our theta increases. So from point number 1 to point number 2. On this graph here, what's happening is that our radius is decreasing. So our point should look something like, our graph will do something like this. Then from point 2 to point 3, our radius is decreasing to negative 1, which means our graph will go something like this. And then from point 3 to point 4, our radius is increasing to 0, which means our graph looks something like this. Then from point 4 to point 5, our graph goes from the point 0, 0 to 1 pi divided by 6, and we're increasing from 0 to 1, Then from 0.5 to 0.6, our R values are decreasing. And then finally from 0.6 to 0.7, since our angles are going from 2 pi divided by 6 to pi divided by 2, we're moving in this direction here, but we're going from 0 to a -1, and so we're moving in the antipodal direction, which means that our graph will do something like this. And so this is a picture of our rows. Now, in this last part, let's go ahead and summarize the different types of equations for roses and polar coordinates. So there's two types of general equation for roses. Either we have r is equal to a sine of n times theta, or we have r is equal to an a cosine of n times theta. And what we get is that we'll have an n-leaved rows if n is odd, and we'll have a 2n leaved rows if n is even. For example, if we have the equation r is equal to a cosine of 2 theta, then we'll have a 4-leaf rows that looks something like this. And if we have the equation r is equal to a cosine, sine of 3 theta, what we just saw is that our rows will have the following general shape.